Until now, we've been dealing with probabilities of very simple situations. For example, the probability of someone out of a group of people having a coffee in the morning. But the real world is a little bit more complex than that. And the models that we have to use to describe the world involve getting a little bit deeper in terms of the probability. So using the example before, we could test or try to study, for example, the number of coffees that people out of a sample of people would take in a particular morning. In this example, you would have then a variable, which would be the number of coffees taken by these people, and the probability associated with each one of these possible results, let's say 1, 2, 3, 4 coffees, would be different. We would then be dealing with a probability distribution in which you would have a random variable, which would be the number of coffees taken in this morning, and associated with each possible result for this random variable, you would have a probability. So let's go over what we have over here. Probability distributions is what we're going to start studying from this moment onwards and until the end of the syllabus. We're almost there anyway. And we are going to study the binomial distribution. We are going to study the geometric distribution and the normal distribution. If you take statistics A2, then you'll learn, actually I start by teaching the Poisson distribution. We are going to study distributions that occur at random and are only discrete. What does this word discrete mean in the context of maths? It means, I think that you already know this, that the values that the variable can take can only be whole numbers. There are situations in which these values can be other numbers, real numbers, but at least in the context of statistics AS, we are only going to study discrete variables, and they are continuous. I mean, they can take any value. We usually will associate with each of these variables a capital letter, which is usually a X or a Y, more commonly an X. So, for example, if you see something like this, X equals 2, what does this mean? This corresponds to the event of the random variable X, whatever it is, taking the number 2. Using the example I used before, if X is the number of coffees taken per day, then X equals 2 means 2 coffees taken per day or per morning. I think I said per morning a little while ago. So what does this mean? P, open brackets, X equals 2. This is the probability that the random variable X takes the value 2. Using the example again, is the probability that one person taken at random from a sample takes 2 coffees per day. In this chapter, we are going to use random variables that are limited in the number of values they can take. They cannot go on forever. They are, because of that, called finite random variables. And I'm going to use another example. Now, the random variable X is what? Is the number of people traveling in a particular model of a car, imagine any model you want, on a highway. And the original data is this. Out of a total of 100 cars sampled, the random variable, again, is the number of people, so this can vary from 1 to 4, okay? And here you have the frequency of the cars sampled that had 1 person in it, 2 people in it, 3, 4 people in it. You already know, you learned this before, that out of this table, you could create a frequency diagram such as this one, all right? And this would be the shape of it. Okay, what does this tell us? This tells us how many, in this case, people are inside the car, and the information is given here on the y-axis. But we can do something more with this graph. What can we do? we can calculate the probability of having a certain number of people inside the car. What do you do in order to get that? It's very simple. You take the number of people corresponding to a particular value for the random variable and divide by the total number of cars. That's what I did over here. So the probability that you have one person would be 0.4. The probability that you have two is 0.3, and so forth. Once you have that information, you can change now first of all the table. This is no longer a frequency. This is going to be the probability associated with the random variable taking a certain number from 1 to 4. And then you can change the y-axis to embed this information in it. If you look at what comes out of this, the x-axis is pretty much the same. You no longer have x here, you just have r. R, don't forget, is a possible outcome for x. What changes is the y-axis. You have now the probability, but the shape is the same. Okay? This is called a probability distribution. All right? The shape is similar to that of a frequency graph, but since it's now focused on the probability of a random variable taking a certain value, is called a probability distribution. You learned before that for frequency diagrams, you could calculate the mean and the variance. When we're talking about the probability distributions, we can calculate also the mean and the variance, but now at least the mean, it takes another name. It's called the expectation. Variance is basically the same concept. Why expectation? Because by calculating this, it will give you information about the most likely number associated with the random variable. All right? How do we calculate expectation and variance? Is basically, if you look at the formula, this may look complicated, but it's just like for the frequency tables. Is much easier done than looking at it. And it's basically the same. All right? Take a look at the expectation. Can also be represented by the mu, same symbol for the mean. All right? It's what? Is the sum of all possible values of the random variable, r, times the probability associated with it. So in this case, it would be 1 times 0.4 plus 2 times 0.3 plus 3 times 0.2 plus 4 times 0.1. Basically the same thing that we did when we were calculating the mean using frequency diagrams. What about the variance? It's the same thing, okay? It's the sum of the possible values of r squared times the probability minus this, and what is this? This is the expectation, the mean, squared. I put here the information as it is written in the MF19. No matter what notation you see, the practical result in calculating these things is always the same. All right? So just focus on one, knowing that they all mean the same. Okay? This shouldn't be more complicated. It should be exactly the same in terms of complexity as what you've learned back in chapter 1. Okay? That's what I have over here. We work with these the same way we worked before. This is the generic information that is valid for any discrete random variable, any probability distribution of such a variable. We are now going to get more specific to actually three different types of distributions, although one of them stems from the first one. More on that later. We're going to focus on these distributions. You're going to learn details about this particular distributions, and then it will be the end of the syllabus. But take this as a generality about any type of probability distribution with a discrete random variable.